Oh, and today we're going to be going over how to solve a pulley mass system problem in Physics 1, such as this. So from the initial problem, it says a 2.4 kilogram block rests on a horizontal surface that does have a friction. The coefficient of static friction is given as 0.5. The coefficient of kinetic friction is given as 0.3. A lightweight string is tied to the block, extend over a lightweight pulley and vertically downward where a bucket is hung. And so the question asked is, if water is gradually added to the bucket, what is the largest total mass, water and the bucket included, that will not cause the 2.4 kilogram block to move right here? So first start off with the information that is given to us. So once again, the coefficient of static friction given is 0.50. The coefficient of kinetic friction given is 0.30, as well as the mass of the block is equal to 2.4 kilograms. So in order to set this problem up, we first need to consider the forces acting on the block as well as the forces acting on the bucket. So for the block, one of the forces acting on is going to be the force of weight, which is going to be equal to the mass of the blocks times the acceleration due to gravity. So that would be 2.4 kilograms times 9.8 meters a second squared, which gives us a value of 23.52 newtons. We also have to take into account the normal force, which in this case is going to be equal to the weight of the block, and it's going to be going in the other direction. But we're going to ignore the signs for this problem, and that's going to give us a value of 23.52 newtons. One of the other forces acting on the block is going to be the maximum amount of static friction possible, or the Fs max. And how we're going to get that is we're going to take the coefficient of static friction times the normal force, which is 0.50 times 23.52, which gives us a maximum static friction of 11.76 newtons. And then there's also a string tension, which we will designate as T. For the forces acting on the bucket, we have the weight, which is going to be equal to the bucket mass times the acceleration due to gravity, as well as the string tension T. And this bucket mass right here is what we're going to be solving for. So the critical condition is when the block is going to start to move. Any additional mass after that is when the block will start to move. So as we stated before, the maximum static friction value is 11.76 Newton. And just before the block moves, the system is going to be what we call a state of static equilibrium, and the friction is going to be at the maximum value, that 11.76 newtons. So this means that the string tension for the block is going to equal the maximum amount of static friction, which is going to equal that 11.76 newtons. Whereas the bucket string tension is going to be equal to the bucket's weight, which is the mass of the bucket's time gravity, because the string tension for the bucket is going exactly in the opposite direction. So in order to solve for this value, we're going to have to set the equation for the bucket string tension equal to the tension of the block and then solve for the bucket's mass. So we're going to take this string tension for the bucket, which is equal to this mass of the bucket times gravity, which is equal to 11, which is going to be equal to 11.76 newtons, which is the string tension of the block. So in order to solve for that, we're going to have to divide both sides by gravity, which leaves us that the mass of the bucket is equal to 11.76 newtons divided by 9.8. And this simplifies to the mass of the bucket is going to be 1.2 kilograms, meaning the maximum amount of mass of the bucket and water before the block starts to move is 1.2 kilograms. And so why this works, so from our work, the maximum bucket plus water mass that will cause the bucket not to move is 1.2 kilograms. So if the mass was less than this, the bucket still would not move. Or rather, the block would still not move, but it would not be the maximum mass allowed. And then if the mass was greater than this, then the bucket would move, leading to the block moving as well. Logically, this makes sense as the coefficient of static friction is 0.5 and the maximum force allowed is exactly half the block's mass of 2.4 kilograms. So I hope this video was helpful in solving a uh, fully mass system problem, and I hope you have a great rest of your day.